So welcome back guys to another video. Topic of today's assignment is clustering. We have just finished the theory part in the previous video and now we will see how we can implement clustering in R. So let's get straight to the overview of the problem shown here. It says XYZ is a large communication company that specializes in providing fast, uninterrupted internet access through broadband. Some examples are Yes India Communication, Gazon India Broadband and Hughes India. Since there will be a multitude of customer types, the infrastructure team has asked the business analytics team to help with quantifying the customers into groups. This way they can better manage the server load and overall technical well-being of the hardware. For instance, they can spread large bandwidth users across different servers so that a single server does not have to handle the total load. The marketing team has also asked that we provide them with the analysis since they can send specific advertising material to different groups. So this is the background of the problem. Now let's start with question 1. It says read the data and make scatter plot and elaborate the observations. So we will read the data and then store it in the variable data_cluster. Then we can check the structure of the data. Now as you can see, there are 6 variables and we have 400 observations. Customer ID variable is a factor variable and rest all are numeric variables. So we have number of emails per day, gigs downloaded per day, then gigs uploaded per day, then gigs saved on server disk and number of log on per day. Gigs here is basically gigabytes. After that, as usual, we can check the summary of the data, but I am skipping this part. You can do it on your own. Then we will check for missing values, and as you can see, there are no missing values here. After this, we'll create a scatter plot. So here we will use pairs function. We could use plot function as well. Just for a change, I am using pairs function. So the first argument is the data. Then the second argument is the label of the plot, which is given by main is equal to server data. And after that, PCH is 21, which is basically a plot character. Different numbers give different characters. So I just randomly mentioned 21 here. Now we can run this and our plot matrix is printed here. Okay, so I will not be explaining the scatter plot here. I have already given in detail the method of interpreting it in the previous video of linear discriminant analysis. You can apply the same rules here as well because those rules are generic. Now if you want to check that out, you can go and check the video. So I will move on to the next question. It says scale the variables with the min-max scaling. Now for scaling, we will use sapply function and supply a customized function to it. We know that sapply will apply the function column wise. So the first argument is our data, excluding column 1. Then we'll create a function for min-max scaling by subtracting the minimum of the variable from each observation in the numerator and then dividing it by the denominator by differencing the maximum of the variable and the minimum of the variable. So this way min-max scaling will be applied on the data. And this can be stored in the variable data_cluster_norm. Now we can move on to the next question that says perform k-means cluster analysis for k values ranging from 1 to 20 and make a scree plot. So before that, here I have given a brief about the k-means formula argument. So let's read it. There are 4 basic arguments that are required in k-means function. First is x, which is your data frame or matrix. This argument must contain all the numeric values. So if you have an ID field, make sure that you drop it or it will be included as part of the centroids. Then we have the second argument, which is the centers. Centers is basically the k of k-means. So centers is equal to 5 would result in 5 clusters being created and so on. Then third argument is iteration.max. which is basically the number of times the algorithm will repeat the cluster assignment and moving of centroids. And fourth one is nstart. So it is basically for attempting the multiple initial configurations and reports on the best one. For example, adding nstart is equal to 25 will generate 25 initial configurations. So value between 25 to 50 is usually recommended. Now let's see how we can implement k-means clustering in R. So for this we will have to use a for loop. So we can set the seed first and then define a vector k underscore values which will have values from 1 to 20 as the question has mentioned. So this vector k underscore values will store the values for center. Then we can create a variable result. This will be a data frame which will store the results. So we can use as.data.frame function along with the cbind function to bind the two columns. So the two columns will be k values and SSE. So basically a value of SSE will be printed against each value of k. So that is the reason we are creating two columns, one for k values which will go from 1 to 20 and the other one is for SSE which will store the values of SSE corresponding to the k values. Now as you can see we are keeping 0 as the initial value of SSE. We will update this using a for loop when we will run the k-means clustering. So let's start the for loop. Now I is going from 1 to length of k values. Now again we don't have to mention length of k values here. We could simply mention 20. I am just showing you a different way of doing it. Plus as we have discussed many times, I prefer not to do hard coding for my codes. So here if you change the k values vector above, then we will not have to change the loop or any other part, but the changes will be made. So that is the benefit if you are not doing hard coding. Okay, now our loop will start. Now here k-means function is written. The first argument is the normalized data. Second argument would be centers, which will vary from 1 to 20. So we will just mention I here. Then we have maximum iteration. Let's give it a number, say 100. And then nstart is equal to 50. As I said above, we generally use values from 25 to 50. Now don't ask me the logic. Let's assume some big shot statistician said this and hence we are following it. After that we can close the bracket. And then if you see we are subsetting the within cluster sum of square using the $sign. And also taking the sum of the overall results. Now why we are doing it? Because we will have more than one clusters. Hence we will get more than one SSE. So our objective is to find the k value for which the total of the within cluster sum of square is minimum. So we are not interested in the sum of square of one cluster. Rather our objective is to find the k value for which the total of within cluster sum of square is minimum. Then only we can claim that our clusters are homogeneous. We can store our output in the result data frame, and as the output is the sum of squares, so we will store it in the second column. That is the reason we have used the $sign and mentioned SSE. Remember we have two columns. First column has k values from 1 to 20 and second column is for SSE. So our objective is to find the SSE against each corresponding k value. Also I have mentioned I within the square brackets so that it can store the results in the row starting from first row and it will go up to 20th row. So this way it will give the SSE values against the corresponding k values which are going from 1 to 20. Now we can run this and the SSE values against the corresponding k values will be stored in the result data frame. After this we will plot a scree plot using the SSE values. So to create a scree plot we can simply use the plot function. The first argument is the k values and the second argument is SSE and type is equal to B, which means we need point as well as line plot. And then we can run it and here you can see our scree plot is printed. Now again an explanation is given here. So let's read the explanation to understand the scree plot. It says from the scree plot above, we can conclude that there is a sharp decrease in SSE initially. And then this decrease is quite flattened with further increase in K values. Hence we can conclude that a 4 or 5 cluster model is optimal where elbow formation can be observed. So we will now select 4 number of clusters for our model, and then we will use k-means function to create that model. So we can use the k-means formula as shown here. The first argument is the data, then center, which is basically the number of clusters, that is 4 in our case, and then n start is equal to 50. We can run this and then store it in the k4 variable. So basically k4 variable stores our best model that has 4 clusters. Now there is an explanation of the output given here. So let's read the explanation and understand the output. So it says k-means has the following outputs. First is the cluster size, which is basically number of points or observation in each of the clusters. Then second is cluster means or center. So we have got a matrix of cluster means for all the variables. We have 400 observations and we got a matrix of 20 centers into 5 variables. So basically it is telling us that this is the average of all the observations from each variable that are there in, let's say, cluster 1, and similarly so on. For example, variable 1, that is number of emails per day, is showing 0.8350 in cluster 1. This means the observation taken in this cluster from this variable has a mean of 0.8350. So this is what cluster mean is. And likewise we can interpret other cluster means as well. After that we have cluster vector. A cluster vector is a vector of integers from 1 is to k, indicating the cluster to which each point is allocated. For example, observation 1 goes to cluster 3, then observation 2 also goes to cluster 3, and so on. Then we have within SS, which is basically the vector of within cluster sum of squares. Then we can also view other available components using the $sign, such as the total sum of squares or total within SS, which is basically total within cluster sum of squares, that is sum within SS, or between SS, which is basically the between cluster sum of squares, that is total SS minus total within SS, and so on. Now we will move to next question, question 4. It says make a prediction for the following 5 new customers using our best cluster model. So recall we have stored the best cluster model in K4 variable that we created above. Now we will use this model to make the prediction for the new data. So we will start by setting the seed. After setting the seed, we will read the new data for making the prediction. And store it in the variable new data. Now we will remove column 1 from this new data because it contains customer ID. So as you can see here, we are subsetting it. Now in this new data, we have only 5 observations. So this is just for demonstration purposes. That is the reason we are only using 5 observations. But the same procedure can be extended to any number of observations. So let's move ahead. Now first we will standardize the data. So for standardization, we will use sapply function. Now this step we have seen multiple times. So I am not going to explain it and we will skip to the next step. So the first question is, how do we assign the cluster to any observation? So basically what we do is we measure the distance of each of the observation from every cluster. And then the observation is assigned to that cluster which has the minimum distance from that particular observation. So that is how we assign clusters to any observation. So for this we will first create a new data frame for storing these distances and prediction. So we can call this new data frame as new data underscore PRED. Then we can use s.data.frame function and create a matrix of 5 columns by 5 rows. Now why are we creating a 5 by 5 matrix? Because we have 4 clusters, so we will have 4 centroids and we will measure the distance of each of the observation from each of the clusters. So each observation will have 4 distances. So those distances will be captured in first 4 columns, and then the 5th column will have the predicted value, means the predicted cluster for that particular observation, which will be decided by the minimum distance of the previous 4 columns. So that is the logic that we are going to use for making the prediction. Now just to make it look good, we will also name the columns of this data frame. So we can use call name function. We will name the first 4 columns as distance 1, 2, 3 and 4. So we can concatenate this using the paste function. The first word is distance, which is denoted by dist, and second is a series from 1 to 4. So this will return distance 1, 2, 3 and 4, which will be assigned to column 1, 2, 3 and 4 respectively. And then the 5th column will be named as prediction. Now we will use a for loop for measuring the distance of each of the observations from each of the centroids and then subsequently making the prediction. Now as we will have to move through the columns as well as through the rows, so we will create a nested for loop. So the first loop will be for rows, which will run from 1 to 5, and the second loop will be for the columns, which will run from 1 to 4. So what we will do, we will first check all the distances of first observation from all the centroids and store them in respective columns from 1 to 4, which is basically distance 1 to distance 4, and then repeat the process for all the rows, that is for all the observations. So that is how our loop will work. Now let's initiate the loop. First we will calculate the sum of squares between each centroid and the new observation. And sum of squares is nothing, but we take the difference of the centroid and the new observation and then sum it. After that we square it to remove the sign in case there is a negative value, and then we take the square root of it. So that is how we calculate the sum of squares. So we are subsetting the center's value from our model, which is stored in K4 using the $sign. So this will return all the centroids. So we will further subset it using J, which is going from 1 to 4. This way we will get our first centroid when J value will be equal to 1, and we will get our second centroid when J value will be equal to 2, and so on up to the 4th centroid. Similarly, for observations which are stored in new data, we are subsetting it using I. Now why we are using I? Because we will check the distance of this particular observation with all the centroids. So this particular observation remain constant for the entire loop when it will run from 1 to 4, and then next observation will come when I will be equal to 2, and then again J will run from 1 to 4, calculating the sum of squares from all the centroids for that second observation, and so on. This way we will calculate 4 distances for each of the observations. And if you remember, that was our goal when we started our loop. And then we will store it in new data underscore PRED. And now we will use these results of new data underscore PRED data frame to make our predictions. So let's see how we are going to do it. So for making the prediction, we can simply take the minimum value of the 4 columns for that particular observation. So we can use which.min function. The argument will be SSE, which we have calculated and stored it in the variable new data underscore PRED, and we will subset it using I, which will return the row number, and column number will be 1 to 4. So it will check the values stored in distance 1, distance 2, distance 3 and distance 4, and will return the minimum value out of these 4 columns for that particular observation. And then we can convert it into numeric form. As I said earlier, if we are getting an output from a different formula, it's always good to convert it into numeric form in case we need that output in numeric form, because we may not know what will be the class of the output which is being written by the particular formula. So it is always advisable to convert it into numeric form. We will store this in new data underscore PRED and subset it using I, which means for I is equal to 1, it will be first row, and the column name where we want to store the prediction. So the column name is prediction. In short, it means when I will be equal to 1, it will store the result in first row 5th column, and when I will be equal to 2, it will store the result in second row 5th column, and so on. So this way the entire loop will work, and in the end we can print our results as shown here. So let's refer to the output table. Now recall when we created the new data underscore predict matrix, we said that there will be 5 columns. The first 4 columns will store the distance between each observation and the 4 clusters, and the 5th column will contain the prediction. Now if you refer to the output table, the first 4 columns store the distances between each observation and the respective clusters, and then the 5th column stores the prediction. Now as we know that this prediction is based on the minimum distance given in the first 4 columns. So if you refer to observation 1, the minimum distance is with cluster 2, hence cluster 2 is assigned to observation 1. And then for observation 2, the minimum distance is with cluster 4, hence cluster 4 is assigned to it, and so on. Now in the end, once again, just to elaborate the loop further, if you refer to column number 1 to 4 of the table, this part of the table has come from first part of the loop, which is this one. And then column number 5 has come from the second part of the loop, which is this one. So I hope this is clear and there is no confusion in understanding the loop now. Again, if you see here, I have given a complete explanation of the loop. So if you are still confused, you can go through it. However, as I said earlier, the best way to remove confusion in loops is to take a small part of the loop and then replace the counter values I and j with a number, and then see what will be the output. So for example, if you want to see what will happen when I is equal to 1 and j is equal to 2, then just copy that portion of the code and run it by putting these values instead of I and j. And from the output, you will easily understand it. Also, you need to be fluent with subsetting for using loops efficiently. I mean, you can see how much subsetting we are using in all our programs. So subsetting is a very powerful technique, and by now you should be comfortable with it. If you are still facing some problems, you can just go on internet and type subsetting in R. You will get numerous examples, and from there you can learn subsetting. Anyways, now we will move to the next question. It is asking us to plot the model and predict the points. So for plotting, we will use the plot functions. So what we will do is, we will create only one plot. And then on that one plot, we will first plot our original data, that is the normalized data. After that, we will show the predicted point on the same plot. So this way we will have only one plot that will have our normalized data as well as the predicted data. So let's see how we are going to do it. Now first we will create a plot of our normalized data. The first argument will be our normalized data. X-axis will be labeled as X and Y-axis will be labeled as Y. After the plot, we will add points to the plot. Now these points will be the clusters that we have created using our model. So we can use the points function, and then for the first argument, we will subset our data, which is the normalized data. And for subsetting, we will use K for $cluster is equal to 1. This will be for adding the first point. Now what this means is, it will return true and false. So whichever observation is falling under cluster 1, it will return true and rest will be false. And then based on the true values of our data frame, data cluster underscore norm will be subsetted. And as far as the columns are concerned, we have mentioned all the columns. Then PCH is equal to 19, just mentioned it randomly, and color will be equal to blue. Similarly, we will add points for the remaining clusters, which is basically 2, 3 and 4. Here we have again mentioned PCH values randomly and assign different colors so that we can have different colors for different clusters. Then we can also add the legends using the legend function. So the first two arguments 0.9 and 0.5 is the position of the legend. So I am just mentioning these numbers randomly. You can plot it and check where exactly you want the legends to appear. After this, we'll mention the cluster names using the C vector as cluster 1, cluster 2, cluster 3, cluster 4. Then we will mention PCH. So I mentioned all 4 values of PCH is equal to 19. Again, just randomly. Then color will be same as we used above. Then I have used another argument CX, which is the number indicating the amount by which plotting text and symbols should be increased or decreased. This is with respect to the default values. Now 1.5 means 50% more, or 0.9 means 10% less, etc. Then the next argument is BTY, which is used to tell if box is required around plot or not. 0 means yes and n means no. So either we can run this and we can plot our points and the cluster, or we can go one step ahead and add the predicted points as well on the same plot. So let's add it here to get the overall picture. So for adding the predicted points, we will again use the points command. The only change will be, instead of the old data, we will mention new data here, and then we will subset it using the new data underscore PRED, where we have stored the prediction result. Give a $sign, give the column where we have stored the prediction. So the name of the column is prediction, and then equate it to 1 for first cluster, 2 for second, 3 for third, and 4 for the fourth cluster. After that, column will remain the same from 1 to 5. We will include all the columns obviously. And then rest of the arguments will remain the same as we did above. We will also add legend here for the predicted values. Again, everything remains the same here. We have just replaced the cluster name by predicted cluster name as shown here. Now we will run this entire code together. Remember, you will have to run this code together. Then only you will be able to add the points. So we can run this, and here you can see our plots are printed. Now if you see the next question, it is asking us to interpret the plot and the clusters. So let's read the answer to understand it. So first is the predicted values. It says in the new data on which prediction is made, 4 observations belong to cluster 2 and 1 observation belongs to cluster 4. So if you refer to the graph, the red circles are the observation that belongs to cluster 2 and the yellow circle is the observation that belongs to cluster 4. Then the next point says the 4 clusters can be interpreted as cluster 1 has lower x and lower y value. Then cluster 2 has x and y around the center. Then for cluster 3, x and y are a bit above the center. Then for cluster 4, x and y is at a higher side on top right. So that is how you interpret the plot and the clusters. Now we'll end this video here and we'll continue this assignment in the next video. So in the next video, we will do hierarchical clustering. And then in the end of the video, we will wrap up the entire assignment. Alright then, so I'll catch you up in the next video. See you.